All right, everybody, we're back with the next lesson in our measurement unit. Now we're going to consider mass in the SI system. So we're going to look at how it's measured in SI, what are the common units, and we're going to look at some conversions. So essentially you can find in this unit that we're looking at, kind of basically what the main topic is, and then we're looking how to convert. And I mean, that's the main part of this unit, is how to convert between different units. We've looked at how basically you have to have that conversion table in front of you the whole time, and there are a few different tricks along the way. Hopefully you're picking up on some of my strategies by now. And finally, please remember that when this lesson is done, this blank will be uploaded into the exercise section. So you need to try the practice questions and look at the practice answers to make sure that you're doing this right. Okay, let's move on. As I said, we're talking about about mass, and they're a little bit into the physics here, but just so you know, mass and weight are not essentially the same thing. You see, weight is based on force. Essentially, your weight, is based on gravity. So just so you know, if you were to weigh yourself on planet Earth, and let's say you were 155 pounds, or well, maybe I should go in kilograms. The point is, let's say you're 155 pounds. And I'm just trying to say to you here, although that's not an SI unit, the point is, if you were on the moon, your weight would change. Because why is that? Because the gravity is not the same. Now you see, mass is the amount of matter within an object. So let's try this a little bit better this time. Let's pretend you had 31 kilograms of mass on Earth. If you were to move to the moon, you still have the same amount of matter inside of you. You would still have 31 kilograms of mass. So yes, I should have used an SI unit here, but my point to you is this. Your weight is based on gravity. What is the force pulling down? Mass is the amount of matter within an object, and that will never change no matter where you go. Okay, I just wanted to kind of define that quickly and kind of get that out of the way. If we look at this here, in everyday conversion, people use terms weight and mass interchangeably. The terms are related, but strictly speaking, weight and mass have different meanings. Your weight depends on gravity. This is what we just talked about. And you will notice, every day you probably, if you were to say to someone, how much do you weigh, or in your own mind you probably talk about that in pounds. But if you, by chance, have your learner's or your driver's license yet, you'll notice that your weight is in kilograms. And I believe when you go to the registry place and get your license, I do think they probably ask you what your weight is. And I believe you tell them in pounds, and the computer probably directly transfers that over to kilograms. The point is, I just want you to know that in Canada, the official system should be in kilograms, which is SI. But my goodness, we use pounds every day. Anyway, I'm going to skip the bottom part here. I'm going to go on to the next page. We're going to go to an example. So it says here, Marty weighed himself on a bathroom scale. He weighed 61 kilograms. Later that day at the store where he works, he lifted 5 dozen 1-liter bottles of water into the trunk of a customer's car. He told the customer he had just lifted his own weight in water. Was Marty correct? Well, first of all, let's figure out how many liters he just lifted there. It says 5 dozen. So a dozen is 12. So 5 times 12. Well, yep, that should be 60. So essentially he lifted 60 liters of water. Now, what we have to figure out here is, what's the conversion? What's going on here? Okay? And that's what I want to focus on. One thing that we will learn about here is we're going to see the connection between liters and kilograms. And the connection that I want to put to you here is that 1 kilogram is equal to 1 liter. Okay? So you have your mass is equal to, so this mass is equal to this volume. So if, give or take, he's 61, but my point to you is this. Give or take, 61 kilograms is equal to 61 liters. So if he lifted 60 liters that day, that's essentially the same as 61 liters, give or take. So yes, he did lift his own weight in water that day, okay? So 60, so what I'm trying to tell you here is 1 kilogram is equal to 1 liter. So the mass and volume have a relationship here, okay? That's what you really, really want to know here. Okay, now, go down here to the bottom, comparing units. So how do different units of mass compare to one another? So I want you to know that 1 kilogram, we're setting this up here now, is equal to 1 liter for water. Now, it's not the same for everything, but in terms, we're just going to base it on water. For now, 1 kilogram. If you have 1 kilogram, it's equal to 1 liter. Now, what else do we know about that? Okay, the other point here I want you to know, please keep in mind, we're going to set this up right here. How many grams are there in a kilogram? Well, again, you could look at your formula sheet. It's on there. We know that there are 1,000 grams in 1 kilogram. Now, what does that allow us to do? Okay, so it says here, remember that 1 liter of water has a mass of 1 kilogram, but 1 liter equals 1,000 milliliters, and 1 kilogram equals 1 kilogram is 1,000 grams. So, where else can we go with this? What else do we know? The one last thing that we can put together here is we know now that 1 gram is equal to 1 milliliter. Okay, that's the other thing that we can do here. So anyway, that's going to kind of help us if you know this, if you know this, if you know this, that's going to make solving these questions a lot easier. Not that this is, a difficult concept. You could probably figure this out based on your conversion sheet, but I want you to know that it's there. So if I am looking at the conversion factors sheet here that I'm going to give you, if you look under, we're in SI, if you look under volume and capacity, you can see right there it says one of them is 1 milliliter equals 1 centimeter cubed is 1 gram. It also says you have 1 kilogram equals 1,000 grams. There's so many ways of looking at this. So I just wanted you to know that all of this is coming into play here, okay? So remember, if you look at this cube right here, I just want to kind of prove it one more point. If you look at the volume of this cube, volume is length, width, height. That's 1 times 1 times 1. So please remember, that is 1 centimeter cubed. It says right here that 1 centimeter cubed is 1 milliliter. So a further conversion that I want you to know, if you have 1 centimeter cubed, that's the exact same as 1 milliliter. And if you look right here, well, heck, if we have 1 milliliter, that's also the same as 1 gram. So now we know that these three things are the same when it comes to water. If you have a centimeter cubed, that's equal to 1 milliliter, which is also equal to 1 gram. By all means, you can write that down on your conversion factor worksheet if you would like. That's not a big deal at all. Okay, let's move on to our next example. Example 2, a Canadian dime has a mass of 1.75 grams. Express the mass of this dime in kilograms. There's so many ways that we could do this. You could look at the table, you could look at your conversion factor sheet, you could do proportions. It is difficult to tell you the best way. What I'm going to do is I think I'm going to show you 2 ways and you can make up your mind. So we'll go type 1. Okay, so what we want is we want 1.75 grams into kilograms. Well, what can we do here? Let's see. What's the easiest way to do here? I'm just trying to think. I don't want to confuse you because there's so many different ways that we could do this. You know what? I think I'm going to stick with the proportion method. Unless you know, like the easy way of knowing this is I know that there are 1,000 grams in, sorry, that's actually 1,000. I know how many zeros are. 1,000 grams in a kilogram. The easy, quick solution is if you've learned this, is you could take a gram and you could divide by 1,000 and that would give you your kilograms. But what if you're not sure? Maybe this is the way I should do it. And then as you become more comfortable, you can go from there. Here's what I would do. I would look onto your conversion factor sheet. You know that 1 kilogram is equal to 1,000 grams. That is straight off the conversion factor sheet. Now, in the question, we were given 1.75 grams. Grams were on the bottom on the left, so we'll put them on the bottom on the right. And this is our question mark. you're going to do that whole cross, multiply, and divide business, which we've been doing over and over here now. The diagonal with both numbers is the 1 and 1.75. So 1 times 1.75 is 1.75. And you divide it by the value not involved in that, which was 1,000. And you get, pardon me, 0.00175 kilograms. Okay? Now, that would give you if you would have done this way, it's the same answer. I'm not trying to tell you which one's better. You see, as time goes on, you will simply know in your head, okay, if I have to go from grams to kilograms, divide by 1,000. If you understand that and you know that, go right ahead and do what's circled right there. It's a lot easier. But until you get the hang of it, I would suggest using this equal proportion method with the cross, multiply, and divide, because that way you know you will not get the answer wrong. This next one here, what is this? It says B, which I guess I can just do right down here, sorry. B says, about how many dimes are there in 1 kilogram? Well, geez, there are, look at this. This is so far from a kilogram. All you would do here, everybody, is you would take 1 kilogram and you would divide it by the mass of 1 dime, which was 0.00175 kilograms. And that gives you, let's see, about 571 dimes. Okay? So please, everyone, please understand what I'm doing here. This is a very easy, quick conversion. I would probably do it myself because I know that there are 1,000 grams in a kilogram, so I divide by 1,000. If that doesn't work for you, and don't feel bad if it doesn't, just use the cross, multiply, and divide way. You'll get the right answer each and every time. Okay, example 3, as soon as this loads. Oh, where did that just go? Sorry, that was on the other page here. Oh, nope, I blew that. So, okay, sorry, that makes sense. I got to fault my paper here. So that's kind of with, some smaller masses. So hopefully that makes sense. Now, if I do this properly, I'm going to go up here. Now we're going to deal with large masses, okay? One thing you've probably come across is the term ton. Okay, now a ton is a pretty big deal. So a ton, which the symbol is simply just a T, no big deal. The ton, I'll just write that in here. The ton is used for measuring large masses, such as the mass of a concrete in a bridge, mass of goods in a truck, trailer unit, mass of an airplane. Now, again, you're going to see an equivalent, something equivalent happening here, okay? Now, here is the deal. If you have, let's say you had a cube that was 1 meter, and if I draw a cube, not just a square, if it was 1 meter in each direction, okay? So that would be 1 meter cubed, okay? That's 1 meter cubed. No big deal there. That's nothing really that exceptional. Now, 1 meter cubed, if you look at your conversion factor worksheet, is equal to 1,000 liters. So I want you to know that. So 1 meter cubed is equal to 1,000 liters. Okay, that's no big deal. So I'm going to put that right here, 1,000 liters. Okay. Now, where am I kind of going with this? I want to put this all together now. Okay. If you have 1 ton, that is the same as saying 1,000 liters. It's also the same as saying 1,000 kilograms. So that's what you want to know. Okay. So it is on your conversion factor worksheet. If you look up, it says there 1 T or 1 ton is equal to 1,000 kilograms. And to take it one step further, we also know that if you have 1 ton, you have 1,000 kilograms, which also means you have 1,000 liters. And we're going to rely on that now to help answer some of these questions. I'll now do example 3 for you. So a Canadian 415 water bomber used in fighting forest fires can hold 6,137 liters of water. What is the mass in tons? Well, let's see what we can do here, okay? So we have 6,137 liters of water. There's not 2 T's, sorry. Of water, and we want that in tons. So what do we know? How can we do this? Well, here's what I do know, okay? If you remember, we'll just go, it's still right here on the screen, okay? It's still right here on the screen. What we know is 1 ton is equal to 1,000 liters. Now, by all means, everyone, if you want, you can add that onto your formula sheet. So I guess what I'm saying is I know that 1 ton is 1,000 liters, which is 1,000 kilograms. Okay? 1 ton is 1,000 liters is 1,000 kilograms. So now I'm going to take that, I'm going to make this up down here. I have 1 ton is 1,000 liters. Now, in the question, they gave us 6,137 liters. Well, where should that go? That should probably go on the bottom, because if you look in the bottom left, I have liters there. So I'm going to put 6,137 liters here. I want this. Cross multiply and divide. So you would multiply those two, hit enter, and divide by 1,000. And that would give you 6.137 tons. It's all based on this connection. I suppose maybe what I should put, what you really, really, really want to know is this is what you should have on your formula sheet, I suppose. You should have 1 ton, okay, is equal to 1,000 liters is equal to 1,000 kilograms. And you see, the best part about that now, if you have that, that's the starting of your ratio. So let's say you want to figure out a question. You now have the left-hand side, because you could say 1 ton is 1,000 kilograms. You also could now say, you could change that. You could put 1 ton is 1,000 liters, and then you could use that to solve something on this side. Hopefully that makes sense. I mean, it's the same procedure we've been using over and over and over, but you know, like, you just have to get the practice with it. There's one more example here I'd like to try. And it's loading. Here we go. You have a big cargo airplane. You can carry 250 tons. So they want it put into kilograms. So what do we know? Remember, we know that 1 ton is 1,000 liters. It's also 1,000 kilograms. So in this question, it looks like we're dealing with tons and kilograms. So I'm going to say 1 ton over 1,000 kilograms. Now, the question deals with 250 tons. Tons were on the top and the left, so they'll be on the top on the right. Cross multiply and divide. I would multiply those two right there. And then I would divide by 1. So in this case, you get 250,000 kilograms. You see, the math here is not difficult. It's just you need to know what equals what. And what you need to know is that 1 ton is 1,000 liters is 1,000 kilograms. And that allows you to go back and forth and set up the ratio. So there are some practice questions here. I will, as always, add this blank copy to your kind of assignment list, and I'd like you to go through all of these questions down here and ensure you can get the correct answers.